Hello, everybody. This is David Price, and wanted to give a little demo video today on my SOC Homelab project. So this is a little personal project I've been working on for the past couple weeks, and just wanted to do a little demo video for its functionality. So I'm going to go over the structure first and the virtual machines I'm using here, and then we can get into some of the attack simulations. So first here, what's currently on the screen is my Splunk server. So this is a Ubuntu server, and it is running Splunk on there. So this is what allows me to host Splunk and access it through the web console, which I will show here in just a minute. But that's the first piece of the puzzle. Next, going over to the Windows 10 VM here. So this, I have a couple of PowerShell windows open right now for to be used in a minute. But this is the victim machine. This is the machine that we're going to be simulating the attacks on. And then last but not least, we have the Kali Linux machine here. I already have one of the attacks starting here because it takes a second to do this Nmap scan. Um, but this is the attacker machine, a Kali Linux VM, doing all of this within VMware. But the those are the three machines I'll be working with there. Now, if we go out here, we can go over to the actual Splunk web UI. So this is what the Splunk server allows me to host here. And in here is where all of the logs are collected, and it will generate alerts based off of what exactly the logs are. So now, to start going back here, the first attack or malicious activity that we are simulating here. It's just a port scan. So this essentially will be scanning all ports. These two options here allow us to collect a little bit more information about the actual processes behind them. And then the output goes into this file here. But essentially, we're using this IP, which is the IP for the Windows 10 VM. And all three of these machines are actually hosted on their own little network, just their own local network. And yeah, so essentially, oh, there we go, just finished. So it found a few open ports here, and we'll actually look at all of the detections there at here at the end. But I'm going to go through a series of attack simulations here, and then we'll go over to the web console and see what it picked up. So the first one here obviously was the port scan. And then the next one here, so we're actually going to use Metasploit. So I'm going to go ahead and type MSF console -q, and that's going to get us into the Metasploit console here. Give it just a second. And once this pops up here, so yeah, here we go, MSF. So now we're going to go ahead and use SMB. So SMB will run over port 445, and that will allow us to do a brute force, because in this case, we're using the SMB underscore login, um, the SMB underscore login feature of SMB. So we're not just doing a simple scan with this. We're going to instead use it for brute forcing. The next command that we're going to have to enter here. So now we're in that functionality. We're going to set our host file or our host to the IP of the Windows machine. So that's one. There we go. And so we have that set. Then we're going to go ahead and set the user, which in this case I created a user on the Windows machine, and that user is a victim. So that's the account that we're going to try and brute force into. Then next we're going to have a set of pass file. So this password file I've already created essentially just has 5 passwords within it that that are not correct, so they will all bounce back as incorrect and create logs for that. So I just created it. It's called wordlist.txt. And then last but not least here, we are setting verbose to true. And essentially what that does is it will spit out in the console here the actual output and show that, we're not getting in and that these are incorrect incorrect attempts to log into the account. So we're going to go ahead and run that. As you can see, all 5 of those failed. So none of those worked there. So that is our second attack simulation. Our next one, and we'll go ahead and exit here, get out of Metasploit. Our next one is going to be suspicious PowerShell execution. So for this one, we actually will not need our Linux machine. We're actually just going to go over to our Windows machine. And this is going to, um, essentially, we're just going to simulate some potentially suspicious commands. I mean, these aren't necessarily always suspicious, but they, could be indicative of a malicious actor trying to, attain information. And so the first one is who am I? Just getting, the current user. Um, Next one is a comprehensive ipconfig command. Then we have a netstack command. And then last but not least, we have task list. So these 4 commands are going to create triggered events for us later. But these are all just potentially suspicious commands that could point to an attacker trying to gain information. So our next potential, our next attack here, or simulated attack, is actually going to be a reverse shell. So we're going to go ahead and open this up here on the Kali Linux machine. We're going to open this up on port 4444. So now it's listening for this, and then we're going to go over here to the Windows machine, and we're going to complete this connection on this side. So we're going to go client. And this was a little bit of a longer command. Okay, so now we should have that connection initiated. As you can see, we have that initiated here. And that will create a specific event occurrence within the Splunk UI, and that will be detected. So don't have to do anything else there, just establish that connection. So we'll go ahead and exit out and end that connection over here. And then the last simulated attack that we're going to do here is actually going to require an admin PowerShell, which is why I have this open over here. And this one's just going to be an account escalation. So this is if an attacker is trying to have an account and they're trying to escalate that account that they have access to admin privileges. And obviously we do not want that. So just going to create it here. I'm going to go ahead and create the account. And then we're going to go ahead and add that account to the administrators group. So like so. Administrators. You go ahead and make that a lowercase a. So yeah, this command will add it to the admin group. And once I do that, that is all I will have to do. And the Splunk UI will go ahead and pick that up and turn it into a triggered alert. So now that we've simulated all 5 of our attacks here, we're going to go ahead and look at the Splunk console, or the Splunk UI, excuse me. And I'll go ahead and show you these 5 alerts. So these are the 5 attacks that we just simulated. And these 5 attacks are actually going to be picked up because each one of these has specific queries in place to have logs that will pick them up. So currently it doesn't show anything because the time is set to all time, or excuse me, all time real time. So obviously we don't have anything currently happening. But if we go over here to our triggered alerts and refresh the page, you're going to see that we have all of the simulated attacks that we just performed. So we have first our port scan, then we have our brute force login attempt, then we have all 4 of the suspicious PowerShell executions from all 4 of those commands. Then we have our reverse shell connection, and then our admin account escalation. So all of these are picked up, and right now I just have them set to show up in the triggered alerts dashboard. And that alone obviously can contribute to a much more effective incident response protocol. But you can also go back here to the actual alerts page. And if you want to, you can go ahead and go in here and you can change what exactly happens. So there's a lot of different options that Splunk gives you when these particular events and alerts are triggered. So you could run a script and you can do things that would automatically, potentially or ideally remediate the situation. But in this case, I just want this to be there for detection and to show all five of these simulated attacks. But essentially, these all operate off of queries, as I mentioned before. Um, these look through all of the events, and just to show what it actually looks like, um, we will go here, and this is all events that will be all of the events that have ever occurred on this machine. Um, oh, excuse me. This is all the events that have ever occurred on this machine. So this will be a ton of events. As you can see, there's thousands, 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 because I've been testing and building this for quite some time now. The actual part that took the longest was figuring out these queries and figuring out how to get the alerts to trigger. But after I figured that out, now everything runs smoothly. And one more thing to mention about the alerts, as you can see, there's a lot of logs to sift through, which is why we need such a specific query. But another thing with the alerts is that um, each of these correlate to an MITRE attack technique, and all of them have either one or multiple techniques that they correlate to. And then one last thing to mention specifically about these alerts, the port scan and the brute force actually run off a schedule, and then the other three are all real-time detection. These two, just because they have to do with a set of multiple actions or repetitive actions, scanning multiple ports and then multiple login attempts, it's better to have a scheduled approach there. Um, but yeah, this is essentially how my SOC Homelab works. So to simulate the function of a security operations center, obviously on a very simple level here. But to go over this one more time, essentially the attacking machine here, the Kali Linux VM, will send simulated attacks and traffic over to the Windows 10 VM. This is our victim, and this will create logs based off the commands that I enter on the Kali machine. And those logs will be picked up and essentially aggregated by sysmon. So sysmonitor is running on this on the Windows machine, and those will be sent over to the Splunk forwarder, which is also running on this machine. And the Splunk forwarder will send it over to the Splunk server, which we have running over here, and that will make them show up on the web UI. And yeah, that's essentially how this works. And so I hope you guys enjoyed this video of me demoing my Security Operations Center style home lab. And yeah, thank you for watching.